Okay, we are finally going to talk about aromatic hydrocarbons. So these ones that I mentioned benzene multiple times before, but it's got these double bonds that are rotatable, or you can say that they have resonance. And benzene is our perfect example of this. Benzene is a very stable molecule, and we use it and is involved in a lot of organic structures. And it's really two cycloalkenes. Okay. And the difference between benzene and an cycloalkane is these have resonance. Remember, if you have a double bond, it can move, right? It can either be here or it can be here. Those are called resonance structures. So I can either have them all bonded like this, or I can shift the double bonds and have it bonded like this. There's two options, right? And they both exist. So a lot of the times you'll see us draw it like this, because that's showing that there's resonance. Both of these exist. It can be either. These are called delocalized electrons. So this 3D structure really tells you what's going on with the electrons. It's not that they're either here, here, and here, or here, here, and here. It's really a blend of all of them, right? If I asked you what the bond order of this was, you would say 1.5, because it's somewhere between a single bond and a double bond. So this is called resonance. These are delocalized electrons. It makes it very, very stable. And so we use benzene a lot. So we do have to be able to name these aromatic hydrocarbons. These are called aromatics. Okay, so first of all, if it is mono substituted, mono meaning one. So if it has one substituent on the benzene, you don't need to number it. You don't need to tell me where it is, because if it's just on one, I assume that that's carbon 1. It doesn't matter, because I can put it on any of those carbons and it's the same thing. So no numbers if it is mono substituted. If it is di-substituted, you do have to have the numbers, because you have to tell me if the groups are on carbons next to each other or carbons across from each other, so on and so forth. And a lot of the times we have some common substitutions. So we've talked about alkyl substitution, so like methyls. We've talked about halogen substitutions, so like chlorine and fluorine. This has some common substitutions. So there's one, if it just has a methyl, instead of calling it methylbenzene, we actually call it toluene. Okay, this one that has an NH2 group on it is called aniline or aniline, and the one with an OH is called a phenol or a phenol group. Okay, so these are common ones you will see. This is straight benzene. These are some substituents. I would know these ones because you are going to see these common names as well: toluene, aniline, or aniline, and phenol. So let's practice naming. Let's name the following aromatic compounds. So remember, these are benzenes. This is benzene, this is benzene. But if it's got substituents on it, it might have a common name. Okay, so let's look at that. So I've got this molecule, and this has an OH on it. So I told you if it has an OH on it, that is called a phenol. And that is where you are going to start numbering. So this is carbon 1, this is carbon 2, this is carbon 3. So this is 3-chlorophenol or 3-chlorophenol, however you want to say it. Okay. This one has a methyl group on it. So the common name for that is toluene. So I'm going to start numbering at that substituent. Okay, so this is carbon 1, and on 4, I have a bromo. So this is 4-bromotoluene. Now this one has 2 bromines on it. It doesn't have a common name. The only ones you need to know are these 3. So this is just a benzene with 2 bromines on it. So you can start numbering at this one, or you could start numbering at this one, but I would say this is 1,3-dibromobenzene.